Hi, I'm Dave from TRC. Welcome to our Heat Pump Boss series, Level Up Your Heat Pump Installs. We've got the tools, tips, and how-tos that will help make you an expert heat pump installer. Today, we're going to focus on how to do takeoffs, windows. Let's dive right in. Let's start with the basics. Windows can be a significant contributor to both heating and cooling loads. Heat loss through glass can affect the home's winter performance, while solar heat gain increases cooling demand in the summer months. Understanding a window's thermal properties and having accurate window inputs are essential to sizing heat pump equipment appropriately. There are two primary thermal properties we care about when documenting windows for Manual J: the U factor and the solar heat gain coefficient, also known as the SHGC. Each measures a different aspect of how heat moves through a window. U factor measures how well a window resists conductive heat transfer. It's basically an indication of how well a window is insulated, where a lower U factor means better insulation and less heat loss. U factors directly affect the heating and cooling loads. U factor is just the inverse of R value, which you may be more familiar with. So a U factor of 0.33 is an R value of 1. SHGC, on the other hand, measures how much solar radiation passes through to heat the space. SHGC is rated on a scale of 0 to 1. You can think of it as a ratio where 1 equals all the solar heat allowed through a window, and 0 equals no heat allowed through. So a SHGC rating of 0.5 means 50% of the available solar heat can pass through a window. For load calculations, the SHGC is only relevant for the cooling load, since the software assumes the heating load happens at night with no solar gains. U factor and SHGC values are typically found on the National Fenestration Rating Council, or NFRC, or from the manufacturer's product catalog. For Windows, the published U factor and SHGC is for the entire window as an assembly, including the framing, sash, and everything else. That's how two windows using the exact same glass will have different U factors and SHGC values. Heat transfers differently through the glass part relative to the framing part, so different framing material like wood, vinyl, or metal, different window sizes, or being double hung versus casement all impact U factor and SHGC. Then other window features matter too. Of course, the number of panes, single, double, triple, has a huge impact. But there is also the use of warm edge spacers, various low E coatings, and what's between the panes, inert gas like argon versus regular air, or a vacuum. With all these variables, it's always best to find the published value and use it as a direct input to the Manual J load calculation. However, if the exact data is unavailable, there are a few other ways to make a good assessment. One option is to see if the U factor or SHGC is marked somewhere on the window, or if a model number is marked, from which you could look up the window on the NFRC database or from the manufacturer. When present, this info may be etched in a corner of the glass or may be printed along the spacer between panes at the bottom of the window. Another option, Manual J load calculation platforms allow you to build the window up from its components parts, or pick from a list of common window types, and it will then assign a default U factor and SHGC for that window. Some platforms only use a few inputs, others allow better accuracy from more inputs. To use the default build-up feature accurately, you'll need to collect data for at least the frame material, the number of panes, and if the window has low E coating. For other softwares, you can input the fill gas, the glass thickness, and the window type, operable, fixed, sliding, and the gap thickness between the panes. One of the biggest impact inputs for window U factors and SHGC is whether the glass has low E coatings. Those coatings reflect the light and the heat that passes between the panes and through the glass, reducing heat transfer. A double pane window with no coatings allows nearly twice as much heat through it as one with coatings. Most windows installed after 1992 have low E coatings. That's when Energy Star labels started to require them. Your first assumption should be low E coated, but you can always double check. Put up a lighter, match, or flashlight to the window. For a dual pane window, you will see 4 distinct reflections, 2 for each pane. If one or more of those reflections has a tinted color, often green or blue, but sometimes pink, yellow, or orange, that's an indication of a low E coating on one of the surfaces. Most commonly, it's the 2 inner surfaces, which would be reflections numbers 2 and 3. Sometimes there will be a coating on just one of the surfaces. Now let's shift to talking about how to input window areas. You could either model them individually, or you could add up the areas of multiple windows for each input. as long as each window in that summation has the same U factor and SHGC, and in the same type of wall with the same orientation. If you want to model the cooling load with high level of detail by capturing the shadow impacts of overhangs and side fins, then you should definitively model each window individually. But for heating-dominated climates, the impact of those shading factors are pretty minor, and you're more interested in getting the heat load exact, so those can be safely skipped in most cases. Speaking of orientation, whether the window faces north, east, south, or west, that also impacts the cooling load. It's still worth modeling correctly, so that Manual J software platforms takes the window's area out of the right wall component, and you have an organized model that doesn't miss anything. And don't forget, doors with 50% of their area count as glazing in Manual J, so sliding glass doors for sure, but even some heavily glazed swinging doors too. Once you have your window areas modeled, it can be useful to take a quick check at window to floor area ratio as a quick gut check on if you have them all. Most homes are between 15 and 20% on this metric. There are some homes with more or less than that range, but you could typically feel the difference in the home with the amount of natural light coming in and the sense of exposure to the outside. And finally, don't forget skylights. Similarly, they'll have a U factor and SHGC rating that's best taken from NFRC values. But if you don't have those, the defaults within the Manual J platform can work. Very few homes have enough skylights to make a substantial impact on the overall heating or cooling load. Here's one area where extreme precision is probably not worth it. Just get the surface area and the number of panes right, and let the defaults do the rest. Thanks for diving in with us on how to do Takeoffs Windows. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.